Now let us learn the section formula as applied to vectors. Let a bar and b bar be the position vectors of 2 points a and b in space, and let r with position vector r bar be some point on the line joining a and b. Then if r divides segment AB internally in the ratio m:n, then r bar is given by mb bar plus na bar divided by m plus n. So here by internal division we are aware that it means point r lies between a and b as shown. On the other hand, if r divides AB externally in the ratio m:n, then r bar will be given by mb bar minus na bar whole upon m minus n. Now in case of external division, the ratio m:n means that it's the ratio of distances of the dividing point r from a and b respectively, right? So here the distance AR is to distance BR, that is m:n. Okay. Now you will see that clearly this is exactly the same formula that you must have already studied in coordinate geometry, but there we had the coordinates x and y. Here it is in terms of vectors, but basically the logic is exactly same. Alright. Now let's prove this section formula, and the proof is again very simple based on the collinearity of points. The theorems based on collinearity of the points and the vectors. So let us write the formula, that is mb bar plus na bar upon m plus n. Let's consider that. Let's first prove for the internal division. It is very much similar for external also. Let's consider a segment AB and a point R, okay, which divides segment AB in the ratio m:n. Okay. Now when we say that point A and B have position vectors a bar and b bar, and point R has position vector r bar, you know that position vectors are always calculated from some origin, right? So although we don't show that, we have to always remember that there is some origin with respect to which we are writing those position vectors. So here let us show those position vectors now. This is a bar, the middle one is r bar, and the third one is b bar, right? Okay, so now clearly what we have is the ratio of AR is to RB, that is m:n, right? So therefore we can write n times the vector AR. Now if you consider the vector AR, then by cross multiplying we get n times AR must be equal to m times RB, right? Now that means AR can be written as r bar minus a bar. Remember, any vector joining 2 points can be expressed as a subtraction of their respective position vectors, that is final minus initial, and RB can be written as b bar minus r bar. So therefore on solving and simplifying we can get the required expression. So that is how the section formula is proved. Okay. In a similar manner we can prove the section formula for external division also, except that the only difference is there is minus sign in both numerator and denominator. Alright. Let's go ahead and see some of the important deductions that we can use as direct formulae. First is the midpoint formula. So if you have points A and B, then their midpoint, since midpoint means the ratio of internal division is 1:1, so therefore we will get the midpoint formula as a bar plus b bar upon 2, right? Now the second formula is a centroid formula which applies to a triangle. Okay. A triangle ABC whose vertices are A, B and C and their position vectors are respectively a bar, b bar and c bar. Then the centroid, which is typically denoted by G, okay, has its position vector given by a bar plus b bar plus c bar whole divided by 3. So it's simply we have to add the 3 vectors and divide by 3. Lastly, whenever the ratio of internal or external division is to be found out, or whenever it is unknown and we have to calculate that, Instead of assuming it as m is to n, a better way is to assume it as k is to 1 and assume that it is internal ratio, okay, tentatively, and solve it to get the value of k. Okay, so find k. Now if that k turns out to be a positive number, then it means that the division is internal, whereas if k is negative, then that means it is external. Right? So let us solve one sum based on this. Find the ratio in which point C, whose coordinates are given, divides the join of points A and B, whose coordinates are also given, and we observe that there are two unknowns P and Q, okay, in this, and we have to also find the values of P and Q. Okay, now here we see that it's given to us that C divides the join of A and B, correct? So as we saw, let us assume that the ratio of that division is k is to 1 and let that be the internal division. Okay. So that means clearly we can write that C bar must be equal to KB bar plus 1A bar divided by K plus 1, since the ratio of division is k is to 1. So therefore we have to substitute now. C bar is, looking at the coordinates of point C, we can easily write C bar, that is minus 2i minus 3j plus k cap is equal to, we have k times B bar, that is k times qi plus 8j minus 10k cap. Now here don't confuse between k and k cap, because if you write just k, it is a scalar. If you write k cap, then it's a vector. Plus A bar, that is 3i plus 2j plus pk cap whole divided by k plus 1. Now you see that when we simplify this equation, collect all the like terms and segregate the I, j and k terms on both sides, okay, we will get an equation which is minus 2 into k plus 1 times I cap minus 3 k plus 1 j cap plus k plus 1 k cap on the left side is equal to, on the right side we have kq plus 3 times I cap plus 8k plus 2 times j cap plus minus 10k plus p times k cap, right? So that means by equality of vectors, if the two vectors are equal, that means their respective coefficients must be the same, isn't it? So therefore that gives us minus 2 into bracket k plus 1 must be equal to kq plus 3, then minus 3 into bracket k plus 1 must be equal to 8k plus 2, and lastly k plus 1 must be equal to minus 10k plus p. Now observe that from the second equation we can directly get the value of k, because there is only one unknown k, and that gives us k to be equal to minus 5 by 11. So here is first answer, that is, since k is negative, it is the external division, right? That is what we saw earlier, and the ratio of external division is 5:11. So that is half part. The remaining part is to find out the values of p and q. So therefore we can substitute the value of k in first and the third equation, so that we'll get the value of p as minus 4 and the value of q as 9.